Hi everyone, welcome to this video. So in today's videos, we are gonna discuss everything which you might be using from this desmos in your SAT exams. I'll be covering all the functions from here, all the functions from here, all the things and the table usage and everything which you need in which you need in SAT exam. So it will be a brief introduction about all the usage of desmos that you will have in SCT. This is going to be a brief video. I will not be explaining the questions. I'm not taking any particular question or anything. But yes, if you go through all of the video, you will be able to understand what all things are there that you can use in SAT. And if you want a detailed video about the questions, how you can tackle different types of questions, I have a playlist already. Uh, Go through that and see how you're doing the different types of questions. But this is a general video. And if you're not doing SAT, still, and if you're using Desmos in your school, so this is still useful. Okay. Now let us start. So we will start with the thing here. Let us see the interface first. So here you have add items. You can add an expression or a table. Okay, adding an expression is just adding another tab here, or you can just click here to add another tab, which is a pretty basic thing. Here you have undo, redo. Okay, settings option. You can close this expression list, open it up. Okay, and here you have the virtual keyboard. Here you have everything. Here you have functions, all of the functions, and then here you can go to the keyboard. Okay, then you have settings options. Settings also I'll talk about what settings you might need when you are talking about different questions. Zoom in, zoom out, or you can just pinch into the screen to zoom out, zoom in, and pinch out to zoom in. If you are, like, let's say, too far on the, like you went very far on the graph section. So, and you want to go back, click on the home tab, you will see the default viewport. Now, first of all, let us go to the table thing. Once we go to the table thing, what will you write here? You will do the points here. Let's take some random points. Let's take 3, 4. So, 3, 4, how will you write? You want to go directly to this thing. Either you can click, or if you're still here, you can click on tab to go to the next tab. Okay, then tab again, then to tab 10, and let's take another point somewhere here. Tab 15, tab 15. Okay, I have 3 points. Now, what we can do with these things. Okay, so let's say you're not seeing your here. Okay, in your default way, you're in your default way, and you're not seeing the points. Click here, and this is zoom fit. Once you click on the zoom fit, you will be able to see all the points which you have drawn. Now coming to this, here you will be, once you insert your table, you will be able to see the add regression. This is kind of a scatter plot now. Okay, this is a scatter plot. What you can do with scatter plot, you can add a regression. Once you click on it, you will see something like this. By default, you are getting a linear regression. Linear regression means Desmos tried its best to approximate your points to a line. And here you have the linear equation. Okay. In SAT exam, from the regression, you will be using linear regression, quadratic regression. Quadratic regression will approximate your 3 points to a parabola. And an exponential regression also you might be using. Exponential regressions you will not use that much, but linear and quadratic you would use. Most of the times you would be doing linear regression only. So this is an exponential curve. So Desmos did it best to approximate it to a exponential curve. Okay, and here you have the exponential equation. And if I set it to quadratic, it gave me the quadratic equation here. So that's all the regressions you will be doing. You will be able to see your y-intercepts, x-intercepts, okay, the minimum points and all. So now sometimes what happens, you might not have exactly the regression. If you want to see what equation it's going to approximate it to, you click on three dots, you'll be able to see the equation. And here, let's say you are clicking on the quartic. Quartic is power 4 equation. And here, see, you can see the equation it's going to approximate it to, where A, B, C, D, all the alphabets, apart from X and Y, are the constants. Now, if you want to delete the regression, you can delete it from here. And if you want to, you have this regression. If you want to export it, so you can export as well. So it gives you the equation. Y1 is approximately equal to m times x1 plus b. Why do you have y1 and x1? Because the table is written as x1 and y1. Okay. Now let's say you might have seen a question where it was telling you that you have h of x, you are given with some points, and h of x is equal to a power x plus b. And you are about to find a and b, and you're given with some points. Okay. How do you do that? Just delete the regression. This is not useful anymore because we don't have any such regressions in the default. So zoom fit if you want to see the points. Here, instead of h of x, you will write y1. Okay. Then you would write approximate. So in the keyboard, go to this ABC, and here you'll be able to see this approximate sign, or you can do it from your keyboard. Then you have a power x, so you'll write a power x and just write 1, it will give you x1, and then plus b. Here it will give you the value of a and b. So you can do any regression in Desmos. You just need to know what you are doing. This way you can set, or you can do any equation. Let's go to quadratic regression again. So I'll do a quadratic regression here. Add regression, quadratic regression. Now what did it do? It gave me a quadratic equation in standard form. Now I do not want it in standard form. I want a vertex form. I need to write the vertex form, okay? I'll do y1 is approximately a parentheses x1 minus h whole square plus k. Okay, see, the graphs are exactly same, no? If I close this graph, the red one, okay, let's say, let's keep the red one. Let's close the black one. See, they are overlapping. These two curves are overlapping because they are exactly same thing. The equation is same, but they are in different forms. Now from here, how can you write your equation in the vertex form? The value of a is this. This is the value of h. This is the value of k. You have it. So you can do any type of regression. You should be able to do any type of regression. Then let's close this for now. Or let me get it back. So sometimes what will happen, let me make an quadratic is fine for now. Sometimes the question will tell you, okay, you are given with this point, these all points, this is your f of x. And they are talking about translations, and they are telling you g of x is equal to f of x plus 5. And tell us the intercept of g of x, any intercept or whatever the question is, how you can do such a thing. So you take your all of the equation copy it. You can copy paste in desmos and paste it here. Okay, instead of f, write f of x. So you're telling your desmos that, okay, this is my f of x. Now you don't need this anymore. So I am deleting it for now. Now what do I need? I need this g of x. So I'll just write g of x is equal to f of x plus 5. Okay, so the purple graph is the graph of f of x and the black graph is the graph of g of x. Okay, our points are on the purple graph, so that's f of x. G of x is this graph translated 5 steps towards the left. Now, or you might have this, or you might have any other function. Let's say h of x. Now they are talking about the vertical translation. That would be equal to f of x. Let's take minus 9. So the red graph is the purple graph translated 9 steps down. The black graph is this purple graph translated 5 steps left. Horizontal translation. Whenever you are adding or subtracting anything to the x, it is horizontal translation. If you are doing some addition or subtraction to the whole function, it is a vertical translation. Now finding the values of a function. Okay, let's close this for now. And let me erase my drawings. Let's say you have this function and they are telling you that find the value of f of 2. Right, f of 2, you have the value. Okay, they are telling you, and you have the same structure of functions. You have composite functions or any such functions. You have to find f of g of x. Okay, and the value of x is, let's say, 3. You have the value. Okay, you have to do f of g of h of x, and you have the value of x as 6. You have the value. Okay, you can do composite functions here or plus 16, anything you can do here. Okay, so functions you can directly do here. It depends on the question, how the question is asking you things, and you'll go accordingly with it. Okay, one thing I wanted to show you more here. Okay, I can't get it back. Let's write a few equations. Y equals to x plus 9. This is my one of the equation. And y equals to x square plus 4x. I have my, okay, 4x. Okay, I have my two equations. Solution is always the intersection. Okay, if the question is telling you about the intersection, if the question is telling you about the solution of the equation, solution of two equations, they are the intersections. And the solution of quadratic, if you have only one equation, let's say quadratic, what is the solution? Solution is x-intercept. So negative 4 and 0 will be your solution in that case. Okay, if I don't have this, I am talking about the solution of this quadratic equation. My solution is negative 4 and 0. But if I have a line as well, and I am now talking about the solution of both the equations, my solution is these 2 points. This point, this point. Now the question might be tricky and they might ask you for the value of x, for solution, what is the value of x when there is a solution, or the value of y. Well, that also depends on the question. What is it asking? Is it asking about the value of x or y? Now here one thing is sometimes you get same colors for both of them. You can change the colors by going to settings. Okay, and then here you can click on the color and use different color and you're done. Click on done and you have the different color. Okay, when will you use this? Don't play with colors in SAT exam. Okay, but when will you use this? If you are getting same colors of the for the graphs and you're not able to identify, yes, go on, use your colors. Now, that was about the expression list. Now let's talk about this is a square. Let's talk about this keyboard. This is X. Okay, let me close these ones. This is X, this is Y, this is X squared if you directly click here, and this is X power anything. So if I'm writing, let me erase it. If I'm writing A power B, it gives me a space here and I can write any power. Let's say 6. Okay, done. And then you have numbers, you have a square root, square of 36 is 6, you have a pi, okay? Then you have absolute value, the absolute value of x. Close the absolute value, you need to close it as well. So you have the graph. Then let's go to ABC. From here you will use this thing. Nothing much you're gonna use from here. They are all constants for, these all are constants for desmos. All these alphabets. You have some brackets here, percentage symbol, and this thing, exclamatory mark. It's basically a factorial, but you won't be using a factorial in the exam. But yes, you can use it like 6 factorial. Okay, it gave you the value, but this is not what you will be using in the SAT. So don't worry about it. This is the only thing that you will be using in SAT, approximate sign, to do the regressions. And this is, let's say you have X, you made a bracket, okay, and you wrote X plus 2, X plus 3, and you want to come out of the bracket, you can use this right click, okay, and left click to navigate through the expression. And this is cross, well, nothing that you can't use. So sine, let's talk about the trigonometrical functions from here. All the other trigonometrical functions will be used the same way. Let's say you have to find sine of 30. Is this the correct value of sine of 30? No, right? Because let's go to settings. My desmos is working in radians. So it considered 30 as radians, not degrees. So I need to set it to degrees. Now this is the value I wanted. And let's say you want to find the angle. So you can use sine inverse of 0.5. Close it, you get 30. This is the angle in degrees. If you want in radians, you can get it in radians. You got 0.52 radians. Okay. So you will get the decimal equivalents only in desmos. That is one thing. Let's go back to functions. That's about trigonometrical functions. Then inverse function, you'll use the same way. Statistics functions are quite useful if you have, let's say, mean of 4, 5, 10, 12, 9. You have the mean, okay? And then you have median. Median of 7. You don't need to sort it or anything. See, I'll write a list which is not sorted at all. It gave me the median, okay? Now let's say some questions are telling you the median of this number minus the the mean of this number, the mean of this list minus 2 times the median of this list. What is the value? So you can actually use it like this is a number now. This whole thing is a number now and you can operate it. So I'll do minus 2 times the median, okay? You can see what I wrote and I got the value directly. These times it is helpful, but in SAT, mostly you will see mean questions where you would be using the sum. Mean is equal to sum over the count. Most of the times you would be dealing with this sum when you are solving the mean questions. Okay, sum will be equal to mean times the count. If you see an average question in the SAT and you're not able to figure out what you need to be doing, maybe try out finding the sum and work out with that. Most of the times it would work out. Well, let's go back to our functions list. You can find mean, median, minimum, maximum. Now, why would you use minimum and maximum? Well, that God knows. But yeah, I'll show you. Minimum, okay, minimum value is 4, maximum value is 12. Okay, you can just type in the functions or you can choose from here as well. Now, let's say you have to find the standard deviation. SET won't ask you to find the standard deviations. Okay, beware of the brackets. Okay, don't put extra brackets. You will see a warning sign like this. Okay, so put the brackets correctly, write the things correctly. Okay. And SAT won't ask you about the standard deviation directly, but it will ask you to compare the standard deviation. Like if the data set got doubled, what is the effect on the standard deviation? Okay. Well, in that case, it will get doubled. But yes, if you're not sure and you are getting like you're in blues, okay, what is this question? Do use it. Don't leave the question. Make sure you do it. Standard deviation, you're going to use quartiles, interquartiles. Not much useful, but yes, you can find them. Total is just the sum of the numbers. Let's say I am doing the total. Total. Now, total you can just do by using the plus sign. Like I have these numbers. Let me just type them in. 4 plus 5 plus 10 plus 12 plus 9. That's your total. Okay, this is what the total is doing. But yes, sometimes might be if you already have a list and you want to find the total sum, no? Like in mean, you want the sum. Use total. Okay, then let's see what else you have. Count is like counting the number of terms, okay? Well, you can just count. But let me just show you, okay? It's interesting to see how many things you can do in Desmos. So you have 1, 2, 3, 4, 5 terms. It gave you 5. Wow. Okay. Histograms, dot plot, box plot, you don't need them. No, not useful to you for SAT. These functions also you don't really use in SAT because you don't have calculus. Well, these are useful. Let me tell about these. Let me close these. Distance. Before doing the distance, let me tell you about some points. Let's say you have point A. If you want to define a point on the graph of Desmos, you need to write capital letter will designate your point. And let me write the point. It is 3, 5. I can label it. It gave me the point. Let's go to the default view. And let me take some point here, -6, 2. B, capital B is equal to -6. And let me take 1. It would be interesting. Okay, so I have the points here, 2 points. I can label them. Now, how will you find the distance? Once you define the points, you can do distance. You have the brackets already. You need to write capital A, comma, capital B. You have the distance between the 2 points. The distance between point A and point B is 9.84. Okay. If you don't want to define the points and all, you can directly write the points. You just need to make sure you write the parenthesis correctly. This is the parenthesis for the distance, and then you write the parenthesis for the point, 1 point, and then you write the parenthesis. Then you write the other point inside the parenthesis. It gave you the distance. Then you have the midpoint as well. Midpoint, P-O-I-N-T. Okay. And I can label it as well. To get the coordinates, it gave me the coordinates. Let's go back and see what else we have. So polygon's distance midpoint. Now, what is this polygon thing? Let me define another point. Polygon thing, I don't know why you would use that, but let's just see. Okay, because we are just exploring our Desmos. Let's take a point here. 4, 4, 4, 4, -4. I have the point. Yes. I can draw a polygon. Polygon between A B, and C. Okay, and tada, you have the polygon in desmos. Okay, again, I don't know why you would use it, but it is there. So, like, you won't be using such thing in this in SCT, but yeah, you should know. Few things you should know. Well, you can also write your points here exactly as it is. Like here you have a point, here you have a point. You can write them. Uh, Most of the students don't know that you have the distance formula here. You don't need to use the distance formula. You can directly get the distance using the desmos. And distance formula sometimes can get hectic to do, okay? So make use of the resources you have. Don't do silly calculation mistake and mess up your paper. Okay, just because you were nervous and were like, oh my God, I am getting the calculation error. You shouldn't get any calculation error because you have calculator. What else? Now you have some numbers here. Okay, so one thing here about the points, if you just want the distance or something in particular, just go use these things, okay? But if you are using the points again and again, you can use this way. Also, you can mark the points. You know, sometimes we have a function and we are just checking whether the point is like you have an inequality. Let me close all of them. You have an inequality. Y is greater equal to 5x plus 9. And you want to check whether your point is in the solution region or not on the solution region. So just write your point, 4, 5. Label it. Oh, it's not in the solution region. Okay, now this point was pretty visible, but yes, this is also helpful sometimes if you're not able to locate the point, or maybe the point is very close to the graph, maybe in decimals or something. That time it might come helpful. Then the last thing that we have is the LCM. LCM is least common multiple. I haven't seen much students knowing this thing, that there exists a thing like this in desmos. So write your numbers, close the bracket. Here you have the LCM. You can find GCD, greatest common divisor. For GCD in SAT, you will see multiple words. You will see GCD, greatest common factor. Sorry, greatest common divisor. You will see greatest common factor. You will see highest common factor. You will also see greatest common divisor. All these four words mean one and the same things. They are not different. But in Desmos, you have GCD. Okay, remember this as well. It is very helpful to find the GCD and LCM of the numbers. Don't use it for variables. Okay, do some for the variables, do some math. Then round is very good thing. If you're not sure about your round off, even if you in SAT exam, let's say your answer is 0.2916666. You have 5 characters for positive answer. 1, 2, 3, 4, and 5. 5 characters, okay? You can write your answer as 0.29. You can write 1. This is acceptable answer. Let's say you are getting this. You got this. Let's say this is another 6. This is what you actually got. This is what you will write in the exam. You can also write 0.292. Okay, so here we learn that SAT is not very particular about your round off. It will accept your answer. You can also start from the decimal itself. 0.2916. Fine. Okay, this is also acceptable. So I guess that will be all. And if you have the fractional equivalent and if that is fitting in your 5 characters, go for that as well. Okay. Or maybe the other possibility here is you are writing 0.2917. This is also fine. It will accept this answer as well. And as I said, there is a fraction. So let's say your answer is 12 over 37. This is a perfectly fine answer. You will get the full marks. Now coming to round, what I was saying about the round. Round, when you do round of 0.2916, oh my God, it's 0. Why is it 0? Because it rounded it to a whole number. And if it write a comma and write a 3, now you have this. So I told him, okay, round it, but round it to 3 decimal places. So this is the number of decimal places. Okay, so it rounded it to decimal places. If you're not very sure about the rounding in the SAT, use it. Okay, don't get confused and don't keep that insecure feeling with you that maybe you have gotten the previous question wrong because of the round off. If you want to recheck, be on the sure side, do use it. But if you are sure, confident, go on, move to the next question. But yes, what happens, some students, they'll keep on rechecking the thing, okay, because they feel insecure. You can kill those insecurities with desmos. So this is a fine, perfectly fine answer, and it's a perfect round off as well. Let's say you want to round to 4 places. You can write 0.2916. Do not exceed 5 characters, write only 5 characters. And if your answer is negative, then you can round to, then you can write 6 characters, okay? Let's say you have the same value, but it is a negative. So you can write a negative 0.29 and 1. So 1, 2, 3, 4, 5, 6. An extra character for the negative sign. Only 5 characters for positive answer, 6 characters for negative answer. That's an extra character for negative answer. Okay. Well, that was about the round. And what else? Let me check. Okay. You have this thing is the root. Let's say you have the third root of 8. That's 2. Or maybe you have third root of x equals to 2. Ta-da! See? Sometimes you won't be able to see the intersections properly because you have these forms of equation. So just zoom in a bit. You will be able to see the value. Okay, it is 8. Then the last thing is nothing. That was all. Okay, so students, it is just up to you how you're gonna utilize all these things in your exam. Mainly, it depends on the question, what the question is asking, and how you might be doing the question, and what the question needs. Okay, so let's say you have some equation y equals to 5x plus 4, and you have another equation x square plus 3. Where is my graph? Okay. Now you have one solution here only. It was asking you about the value of y, but you gave the value of x. So it is wrong. Okay. Make sure what the question is asking you, whether it's asking x or whether it's asking y. That is also a common mistake that students do. Okay. So practice all of this, and I will see you next time. Best of luck for the exams. Bye-bye.